Good day, this is the Professor, CBMD PhD, and today's Monday, May 22nd, 2023. It is 10:21 and 23 seconds, AM Eastern Daylight Time, and today's research, Kilonova. So let's jump to it here. Astronomers uncover a 1 in 10 billion binary star system, Kilonova, progenitor system, late February 1st, 2023. Source: Association of Universities for Research in Astronomy. Researchers confirm detection of a star system that will one day form a Kilonova, the ultra-powerful gold-producing explosion created by merging neutron stars. These systems are so phenomenally rare that only about 10 such systems are thought to exist in the entire Milky Way. And this unusual system, known as CPD 292176, is located about 11,400 light years from Earth. The SMART's 1.5 meter telescope allowed astronomers to deduce the orbital characteristics and types of stars that make up the system. A neutron star created by an ultra-strip supernova in a closely orbiting massive star that is in the process of becoming an ultra-strip supernova itself. An ultra-strip supernova is the end-of-life explosion of a massive star that has had much of its outer atmosphere stripped away by a companion star. And this class of supernova lacks the explosive force of a traditional supernova, which would otherwise kick a nearby companion star out of the system. The current neutron star would have to form without ejecting its companion from the system. An ultra-strip supernova is the best explanation for why these companion stars are in such a tight orbit. As to one day create a Kilonova, the other star would also need to explode as an ultra-strip supernova so the two neutron stars could eventually collide and merge, as well as representing the discovery of an incredibly rare cosmic oddity. Finding and studying Kilonova progenitor systems such as this can help astronomers unravel the mystery of how Kilonova form, shedding light on the origin of the heaviest elements in the universe. As for quite some time, astronomers speculated about the exact conditions that could eventually lead to a Kilonova. These new results demonstrate that in at least some cases, two sibling neutron stars can merge when one of them was created without a classical supernova explosion. And producing such an unusual system, however, is a long and unlikely process. We know that the Milky Way contains at least 100 billion stars, and likely hundreds of billions more. And so this system has the right stuff to eventually form a Kilonova. It will be up to the future astronomers to study that event. It will take at least 1 million years for the massive star to end its life as a titanic supernova explosion and leave behind a second neutron star. And this new stellar remnant in the pre-existing neutron star will then need to gradually draw together in a cosmic ballet, slowly losing their orbital energy as gravitational radiation. When they eventually merge, the resulting Kilonova explosion will produce much more powerful gravitational waves and leave behind, in its wake, a large amount of heavy elements, including silver and gold. As this system reveals that some neutron stars are formed with only a small supernova kit, as we understand the growing population of systems like CPD 292176, we will gain insight into how calm some stellar deaths may be, and if these stars can die without traditional supernova. And this is a professor, astrophysicist of advanced mathematics, computer science, and later of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.